Welcome all my geometry students and geometry students that are not mine. All geometry students, I should say. Welcome to 3.1 to 3.3, Parallel Lines and Transversals. A great section we have. At the time of the filming, it is October, so that means it's going to be a spooktacular month. So I hope you enjoy this video. Parallel lines is what we're talking about here. So parallel lines, what is the definition? These are coplanar lines. So coplanar lines that don't do what? Don't intersect. So they don't intersect. Think roads. So if you have two parallel roads that they don't ever cross, that don't have a traffic light or a four-way stop, that means they are parallel, that they don't cross. Coplanar means they're on the same dimensional surface, so it's not like airplanes or something like that. Okay, same playing field. Now, let's do the diagram first. Okay, I don't know how great of a job I did, but anyway, here we go. Here's our diagram. Now, just looking at it, you can't assume. So you can't assume it's parallel. You really need to see these two things. You need to see these little carrots. So those little carrots indicate, those little arrows, as other people call them, indicate that they're parallel. And they need to have the same number. For example, if there were 2 on this one and only 1 on the other one, then they're not parallel. But if they both have 2 or if they both have 1, then they are parallel. So that's the diagram. That's how you can tell by looking at a diagram. What if it was just symbols? We would have AB, line AB. Make sure you have 2 arrows on top. Then we have line FR, line on top. And then this little symbol in between. What a weird color. Let's go here. And let's open this up a little bit. Maybe a little bigger, sorry. That little symbol right there that I highlighted in yellow, that means parallel, okay? 2 parallel lines indicate that it's parallel. So that's parallel lines. I'm guessing you guys have heard of that one before. Skew lines you may have not heard of, but you may have heard the phrase, oh boy, things are askew. That means we have non-coplanar lines. Oops, not no. I meant non. Let's go, and not like non-bread. I mean like non as in N-O-N, non-coplanar lines. They are not parallel, and they don't intersect. Like, whoa, how, if they're not parallel, that means they intersect. No, because they're in different dimensions, okay? Not different dimensions as in like Twilight Zone or Star Trek or something. Not parallel and not, what did I say? Not parallel and don't intersect, that's right. I'm talking about they're in 3D space and they're going in different directions. So if you look here, blue is going like front to back. Think about coming out of your screen and then into your screen, whereas red is just going up and down your screen. If you continue this blue line with the noise, it's not going to cross the red, but they're not parallel because they're not coplanar and they're not moving in the same direction, okay? So that's what skew means. Now, it's pretty basic. There's no symbol for it really, but we have CR and MO lines are skew. That's how you write their skew. It's kind of pathetic, honestly. There should be like a symbol. It should be like or something like that. I don't know. I guess that's why there's no symbol, because mine stinks just as much as that. Parallel planes. This is simply planes that don't intersect. Planes that don't intersect. Think about floors, like different floors of a building. Okay, so if you have one floor and then a floor below it, they're not going to intersect. Would there be some serious problems with that building, the integrity of the structure, if those floors were intersecting? So that's what parallel planes are. They don't intersect clearly, as you can see in the diagram. So we have plane, and we can label it with 3 letters. Let's call it AQR. Why not? Parallel, the same parallel symbol, and then plane IMT. Remember, we label planes with 3 letters. Okay. So those are parallel. That's kind of like the basic pre-part. Let's get into the more interesting part. In my opinion, transversals are really cool. What is a transversal? It's a line that crosses 2 or more lines in the same plane. Okay, so they have to be coplanar. I should have said coplanar lines. Okay, that'd be a way to shorten it up a little bit, but coplanar. Okay, we're not talking about 3D space, we're talking about flat surface. Okay, if you guys didn't notice, that was me hitting my flat surface table in front of me. Okay, so what does that mean? Well, let's look. We have a couple lines here. Which one is the transversal? Remember, it has to cross 2 or more. First, you'll notice that they're all in the same plane because they're all flat. Second thing, which one of these crosses 2 or more? Well, you see that we have 2 intersections here. The line that's on both those intersections is this guy. So this guy is the transversal. Trans means from one to another, okay? So transport means you move from one place to another. So transversal is you cross more than one, okay? You move from one line to another, so transversal. Okay, like if you transverse a country, traverse a country, okay? That's where the root of the word is. Okay. Now let's get into another one here. Which one is the transversal? Looking at this diagram, I hope you guessed T. This is the transversal. Okay, and now we're going to talk about the different relationships that a transversal forms with 2 lines. Okay, and we're going to get into this more in the next section also with parallel lines. But for now, we're just talking about an intersection of 2 lines, not necessarily parallel. You'll notice here that it naturally forms 8 little angles, okay? The 2 intersections form 8 distinct angles. Now, these angles have a relationship with each other, and they have special names, okay? But before we get into the names, we need to kind of identify, let's talk about this space that's created here. Notice how we have this space in between the 2 intersecting lines that's formed. Okay, see how that's like on the inside of those two lines there? It's almost like a green sandwich between L and M. This is known as the interior space. Okay, therefore the blue would be the exterior because it's on the outside of those lines. Okay, so this is the exterior. That's the first important thing. The second important thing is this transversal will give us a lot of clues on how to name this also. So we have to be aware of this transversal. Are they on the same side of the transversal? Like for example, all of these points are on the same side of the transversal. They're all on the left side. Or are they on the other side of the transversal? All these points are on the same side of the transversal. Okay, they're all on the right side. So that's an important thing to know as well. So let's go ahead and get started. Alternate interior. First thing you should notice is we have interior. Well, that means we are going to be looking at all the points inside here, okay, in the interior. So we're only looking at 3, 4, 5, and 6. Okay, those are the 4 angles we're looking at. Now, alternate. Alternate means we're looking at alternating sides of the transversal. So, for example, 5 and 3 are on the same side, so they are not going to be alternating. 5 and 4 are alternating on either side of the transversal. So here's our first one. Let me increase the size a little bit, angle like this. So angle 5 and angle 4 are alternate interior angles. Let's go over here, match the color, angle 5 and angle 4. Now, what about angle 5 and angle 6? Technically, they're on the interior and they're on alternate sides of the transversal. But we already have a name for them. These two are supplementary. So we don't want to include supplementary angles with this because that's already an established relationship. Okay? Next one. We have, let's stay with green. Let's go with this like laser color. We have 3 and 6. Those are on alternate interior, or they're on alternate sides of the transversal and they are on the interior. So we have angle, I hope you guys can see this, angle 3 and, let me put this vertically actually. Angle 3 and angle 6. So those are the alternate interior angles. That's it. There's only 2 pairs, so 4 total. Alternate exterior, same deal, but now we're talking about the outside. So let's use, I guess, this blue color. Yeah. So now we're not talking about the same side. We're talking about alternating sides. So, for example, 8 and 1 are on alternate sides of the transversal, and they are in the exterior, angle 8 and angle 1. I said that backwards. You guys get me. Angle 1 and angle 8. Okay? That means 2 and 7, same deal. We have 7 and we have 2, and they are also alternate exterior. So angle 2 and angle 7, alternate exterior. And again, there's only 2 pairs of those as well. Okay, so now we have all our angles highlighted, so we're going to have to find another way to designate these for same side interior. Now, we already kind of established this. Hopefully, you should be able to figure it out. Maybe pause this video and guess to see if you can figure out what the same side interior angles are. You didn't pause it, did you? Whatever. Okay, so I'm going to go up here, if you didn't pause it, and I'm going to show you which ones are the same side interior. So let's go ahead and use orange. So we're looking at the same side of the transversal and also on the interior. That would give us angle 5 and angle 3. So angle 5 and angle 3. Angle 5 and angle 3 are same side interior. By the same token, we look at the other side and we see that angle 6 and angle 4 are also same side interior. So angle 6 and angle 4. Now, same side exterior is really not a thing. I don't know why. I guess it could be a thing, but it's not. Someone just decided that same side exterior doesn't get their own thing. So moving on to corresponding. So corresponding is the last one. This is probably the trickiest one for most people to understand. And it's because we need to look at the intersections. So as you look at the intersections, you'll notice that we have like an upper right. So we have a right upper and we have a right lower. And then we have a left lower, and then we have a left upper. This is always true. You're always going to have this. So same deal here. You're going to have right upper, right lower, left lower, okay? So that's something to keep in mind. I'm going to undo this just because I just wanted to show you, but it's kind of hideous in my opinion. Okay, so now we need to establish what that means, okay? So corresponding means they're in the same part of the intersection. Okay, the same part of the intersection. For example, what can I do here? I guess I'll make like little stars, or maybe make it pink or dark purple. Yeah, I'll do dark purple. Okay, so angle 6 is in the upper right part of the intersection, as I showed earlier, and angle 2 is also in the upper right portion of the intersection. So that means they are corresponding angles. So angle 2 and angle 6 are corresponding, okay? Because they're in the same part of the intersection. Even though they're in the 2 different intersections, they're in the same part of the corresponding, see the word there, intersection. Angle 1 and 5, same deal. Okay, they're in the top left. Angle 1 is in the top left. Angle 5 is in the top left. Okay. Let's go down. Can you guess the next one? So angle 3 and angle 7 are both in the bottom left. So we have angle 3 and angle 7. And the last one, we have angle 4 and angle 8. So what can I do here? I'm trying to think of something. Maybe like a little circle. There we go. Angle 4 and angle 8. I guess that's what I can do. So those are the last one because they're both in the bottom right of the intersection. Okay, that's all I have for you today. Just make sure you understand this part. It's going to be super helpful when we move on to the next section. Thank you so much for watching. I'll see you next time.